Today we are going to be subtracting two numbers, 8 and 3. We're going to set ROM 0 to 8, that's binary 1000, and then ROM 1 to 3, which is binary 0011. I need to set the write pin to 0, the accumulator output to 0, and the read pin to 1. We want to read the 3 value first, so we're going to set the address to 1. I am going to flip the A or B switch. Then I will flip it back off. This will set the data to be routed to the store B register. Then we will set enable to 1. We will then run a clock pulse by flipping the clock input to 1, then back to 0, and the store B output value will change. Set enable back to 0. And now we will set the address back to 0 to read the value 8. A or B pin will now go back to 1. We're now ready for our second value to be put into the ALU. This ENACC pin will also be flipped to 1. We will then run a clock pulse, and the accumulator register should now hold the value of 5. Congratulations, you just subtracted 8 and 3. You now have 5, but we need to store this value somewhere. Set ENACC back to 0. Now if you run a bunch of clock pulses, the values should not be changing. Now we need to set accumulator out, and this will send the data into the memory bus. There is currently a memory bus error. This is because data is coming from both the accumulator and the first ROM. All we have to do is set read back to 0, and this error will be resolved. We now need to save our new number into memory, so set the write pin to 1. We're going to set the address to 6, which is binary 110. And then you run 1 clock cycle, and the value 5 should be stored in RAM slot number 6. This machine is digital because it uses discretely on or off signals. If it were analog, it would be using different voltages to do different calculations, but it uses specifically binary numbers. A bit is a unit or a digit of binary value. The registers in this microprocessor are all 4 bits. A register is a unit inside the microprocessor that stores data, usually binary data. Registers are important for computers because in order to do math, we have to store values in order to perform our calculations, because it takes multiple clock cycles to perform these calculations. It's also good for storing data for longer term purposes, for example, memory, to be used later. The registers can be found in these 5 spots. 3 of them are in the RAM, and 2 of them are right around the ALU. These are all parallel in and parallel out registers, because we are sending multiple bits in and out of each register. Thank you for watching.